2. So we have another quotient rule here. So I need to find b prime of x, which is going to be low d high minus high d low all over low squared. So if I want to find b prime of 3, I'm going to plug 3 in. Now, it's very important that you guys make sure that you show all of your work here, because on the AP test, sometimes if you make a mistake but you showed your work, they'll still give you some credit for it. Okay, so make sure that you show every single step along the way. It also makes it so that you guys don't make mistakes. So g of 3 is going to be 2. F prime of 3 is going to be -6. F of 3 is going to be 4, and g prime of 3 is going to be 5. All of that divided by g of 3, which is 2, squared. So when I go to simplify that, I'm going to get -12 minus 20 over 4, which is going to be -32 over 4, which is going to be -8. So I know that b prime of 3 is going to be -8. Okay. All right, let's try another one. Now this one, you guys will notice, actually, it's not a product or a quotient, which sometimes confuses you guys because we practice so much with the products and the quotients, but this one's actually going to be a lot easier because the derivative of f of x, I know, is just f prime of x. And it's a sum of different power functions, so now I know that the derivative of g of x is just going to be g prime of x. There's no really rules. We're just doing straightforward derivatives there. So if I want to find p prime of 3, that's just going to be f prime of 3 plus g prime of 3, which is going to be -6 plus 5, which is -1. So, oops. So p prime of 3 is going to be equal to -1, which, remember, is basically telling you the slope. So this, just a reminder, this is the slope of the tangent line in p of x, so our new function, at x equals 3. You can also call this the instantaneous rate of change. Okay. All right, moving on up. We got one that is a little bit more tricky here, but we're still going to use our same derivative rule. So I have a quotient here. So even though I have a quotient with a difference at the bottom, that's okay. I'm going to do low. So the low is still going to be f of x minus g of x, the whole thing. And then the derivative of the high is going to be f prime of x minus high. Now I know that the derivative of that low one is going to be f prime of x minus g prime of x. And here, actually, it is kind of nice to use brackets just so you can differentiate between your sets of parentheses over the low function squared. Okay, so if I want to find c prime of 3 now, c prime of 3 is going to be f of 3 minus g of 3 times f prime of 3 minus f of 3, f prime of 3 minus g prime of 3. It's starting to sound like we're talking a different language here, but I think you guys are getting the hang of it. It's getting complex and you're understanding, okay? So let's go and do this. So f of 3, using the information they give us, f of 3 is 4. G of 3 is going to be 2. F prime of 3 is going to be -6 minus f of 3 is going to be 4. F prime of 3 is going to be -6 minus g of 3, which is going to be 5. All of that over f of 3 minus g of 3 squared. So f of 3 is going to be 4 minus g of 3, which is 2 squared. All right, so now we got to make sure that we're careful with our order of operations. So I like to go step by step. 4 minus 2 is going to give me 2 times -6 minus 4 times -11 over 4 minus 2 is 2 squared. So I get -12 plus 44 over 4. So -12 plus 44 is going to be 32 over 4, which is going to give me 8. So I know that C prime of 3 is going to be equal to 8. And that's my final answer. Okay, so they get a little bit different looking, and you're going to see some different varieties, but you have to realize that you're just doing the same process over and over and over again. And the more work that you show and the more organized that your work is, the easier calculus is going to be for you. So it's definitely a class where you can't do a lot of work in your head. You have to really just start writing stuff out and solving it. All right, this is a different notation. We haven't really seen this notation yet, but this d dx, you guys know that means find the derivative. We've talked about that. This is giving you the function of h of x over x, and this is just telling you at x equals 2. Okay, so they just really didn't give this function a new name. Like up here, they gave our new function f of x. They gave our new function c of x here. They didn't really give it a new name. They just wrote it in a little bit more complex notation. So I want to make sure that I find this derivative first. So the derivative of h of x over x, I'm just going to call this dy dx, is going to be low d high minus high d low over low squared. So now if I want to find dy dx at x equals 2, I'm going to say, all right, well, I know that that's going to be 2 times h prime of 2 minus h of 2 times 1. I'm just going to skip out on writing that. So that's going to give me 2, and then h prime of 2 I know is -3 from the original equation. And I know h of 2 is 4 over 4. So my final answer, and I'm going to write it in the same notation that they started with. Okay. So when you have some things that are written a little bit more complex that aren't just, h of x and g of x and you have an x thrown in there, you're still going to do the same thing. And actually, I think it kind of becomes a little bit easier because the derivative of x is just going to be 1. All right, another graph one. So if I want to find q prime of 7, well, q of x is f of x over g of x. So let's find q prime of x first. I know that I'm going to have low d high minus high d low over low squared. Q prime of 7 is g of 7, f prime of 7 minus f of 7, g prime of 7. So I haven't even looked at my graph yet. And if this were an FRQ, you actually might already have 2 points given to you just for showing me that you know how to find the derivative and that you know how to plug that number in. That's a lot in calculus. It's just showing me those first couple steps. So we're talking about at 7. So 1, 2, 3, 4, 5, 6, 7. That's going to be right here and right here. So let's figure out what my point is. So f of 7 is going to be the point at 7. So that's going to be 1, 2, 3, 4. And f prime of 7 is going to be the slope there. So if I look at the slope, it's going to be up 1 over 4. Okay. Now if we look at g of x, g of 7 is going to be 1. Oops. And g prime of 7 is going to be the slope here, which actually is going to be -2 over 3. Okay, so that's what we're going to want to go and plug in to our formula. So g of 7 was 1. F prime of 7 is 1/4. Minus f of 7 is 4. G prime of 7 is negative 2/3. All of that over g of 7 squared, which is 1. So 1 squared is just going to be 1. And now remember, if it's an open response question, leave your answer just as that. You don't have to simplify if it's open response. Now, if it's multiple choice, you do have to know how to simplify. You just don't have to always do it. So that's going to be plus 8/3, right? Over 1, doesn't really matter. Now I got to add these together. So I'm going to get a common denominator. So 1/4 is really going to be 3/12. And then multiply that by 4, multiply the top by 4. So I'm going to come out with 35/12. Okay. All right. Now, the last ones that I want to go over are the ones that are the definition of the derivative. So, recognizing the definition of the derivative. So this is the formula that we learned way back when, a couple weeks ago, that is actually just finding a derivative, right? This is basically f prime of x. But what you guys have to do is, unless you want to solve that all the way out by hand, which I don't even know if we can do that, we need to be able to tell, all right, this is the definition of the derivative, okay? We know that the x value is always right there in the parentheses. So I know right here that x is pi/2, okay? My function is always out in the front. So my function here is going to be sine of x. Oops. Right? Because remember, when we go and we plug into the definition of the derivative, you have to plug in x plus h. So here I have pi/2, so I'm plugging in pi/2 plus h in for the x spot, okay? So once we realize that, we also want to double check, is this is going to be f of x, so is this the sine of pi/2? Yeah, the sine of pi/2 is 1, so we really have f of x plus h minus f of x over h. So all this is asking us to do is to find the derivative at pi/2. So the cosine of pi/2 is going to be 0. So I know that my final answer here is going to be 0. Okay. Next one. Same thing. I know that this is going to be my x value. I want to look here to find my function. Right? And then I want to just double check. Is this f of 4? So ln of 4, yep. You can't even simplify that, so they just left it as ln of 4. So all this is asking me to do is to find the derivative, which is going to be 1/x. And then they want me to find f prime of 4, which is going to be 1/4. So my answer here is 1/4. Okay. All right, next one. Again, this one looks a little funky because it has exponents in there, but really, we still want to look there next to that h. So I know that my x value is going to be -1, okay? You can think of this as being in parentheses, but they didn't put parentheses because it's up in the exponent. In front of the parentheses, I have f of x equals e to the x. Okay, so basically you want to take out that whatever number plus h is. Take that out, and that's going to tell you what your function is. Okay, double check. This should be e to the x, e to the -1. Is e to the -1 the same thing as 1/e? Yeah. So all this is asking me to do is to find f prime of x, which we know the derivative of e to the x is still e to the x. So f prime of -1 is going to be e to the -1, which is still going to be just 1/e. Okay, which e is such a crazy function in calculus because a lot of times it doesn't change when you do your function and your derivative. Unless we get into the chain rule later on, you'll see that it might. but the basic e to the x will always stay e to the x. Now we have our alternate definition of a derivative, right? So here it's actually a little bit easier because this is going to be your function right here. So this is sine of x, and then this down here, any of these, are going to tell you what you're finding it at. So I want to find, this is basically saying f of x is sine of x, and I want to find what is f prime of pi over 3. Okay, because I know that I do f of x minus f of a, so this is the sine of pi over 3, right? So the sine of pi over 3, if you do your hand trick, pi over 3 is going to be root 3 over 2. So let's find f prime of x is going to be cosine of x, and then f prime of pi over 3 is going to be the cosine of pi over 3, which we know is going to be cosine of pi over 3 is going to be 1/2. So that's my answer. Okay. And then the last one, we have natural log, so I know this is going to be my function. And I know that this is going to be my x value. So this is basically saying, double check, is this the ln of, if you plug this number in, is that what you get in that second part? And it is. So I'm going to find f prime of x is going to be 1 over x. So f prime of, of 3. Oops, that's right. F prime of 3 is going to be 1 over 3. So my answer there is going to be 1/3. So by recognizing the definition of the derivative, you guys can really get a good understanding and save you a lot of time, because these would be super, super, super complex to actually go through and solve mathematically. Okay.